All right, guys. Your central question for today is, how do we graph logarithmic function? Your vocabulary is logarithm, inverse, domain, and range. All right, so just before we go over what logarithmic graphs look like, let's take a second and review the general form of exponential functions. If you remember, exponential functions, general equation, resemble this: y is equal to b to the x, where the b stands for your base. And so, and it's not working, where b is greater than 1, that means it's exponential growth. So if you look at the graph that's right here, you notice that it is exponential growth, and it goes through the point y-intercept 0, 1. And if you look at some characteristics of it, you'll notice that the domain of your exponential function is all real numbers. The range of the exponential function is y is greater than 0. It is growth, and it has a y-intercept of 0, 1. So a very interesting thing happens when you have a function and its inverse from a geometric standpoint. And so if you actually remember or recall with an inverse function, if you remember some symmetry, you're able to map the inverse of a function is simply the reflection of that function across the line y is equal to x. So I can already get an idea that this would be the shape of my log function in blue, because in red that's the exponential, and if you reflect that across the green dotted line that represents y is equal to x, then blue would be your image that you would get. And so that's what the basic log function looks like. So let me just show that to you a little bit better on the next slide. So if you notice the red exponential graph and then the blue logarithmic graph, and if you put both of those on the same coordinate graph, and notice that the graphs of inverse functions are reflected about the line that's in green, y is equal to x. So in blue, that is what the graph of the logarithmic function is. Now notice that there are some similarities, that there is an asymptote with a logarithmic function, just like there was an asymptote with an exponential function. The asymptote for an exponential function was a horizontal line. The asymptote for the logarithmic function is going to be a vertical line. And notice how the logarithmic function increases, doesn't necessarily level off, though, it just continually increases slowly and slowly over time. So, relationships between exponentials and logs. Remember, logarithms are the inverse of exponentials, so there is some relationship there. They're inverses of each other. So, exponential characteristics are on the left, and if we look at the characteristics of the log function, the domain of the log function is x is greater than 0. The range is all real numbers. Its x-intercept is 1, 0, and its asymptote x is equal to 0. That's all fine and dandy unless you move and make some transformation. So first thing that I would suggest you do for a logarithmic function is determine where the asymptote is. To determine where the asymptote is, I need you to think opposite. So for example, I wanted you to graph this function, log base 2 of x minus 4. First thing I would want to know is, well, where is the asymptote of this function is? And it's opposite, so it's at x is equal to 4. Next one, the asymptote would be at x is equal to negative 3. Next one would be at x is equal to 6. And the last one would be at x is equal to negative 9. So there's your first step, to determine where the asymptote of the function is. Once you know the asymptote, then we can actually graph functions. So let's say I want you to graph this, log base 3 of x plus 1. First thing you'd want to know is that the asymptote is at x is equal to negative 1. So if I drew a graph from over here to negative 1, I would put my asymptote, my dotted line. So 1, 2, I want to do this in green. 1, 2, 3, 4, 5. All right, so there's my asymptote. Now, to do the actual graph, I want to make a t-table, so x, y. I want to pick numbers that are bigger than negative 1. If you try numbers that are smaller or equal to negative 1, your calculator will either say non-real calculation or undefined. Numbers that are bigger than negative 1, so I'm just going to pick 0, 1, and 2. So it's very easy to put these into your calculator So I'm just going to pull this up. It's log base 3 of x plus 1. So you can just do log base 3, and then we chose 0 plus 1. So it's log base 3, and then we said 0 plus 1, so that gives me 0. Okay, so 0. Alright, so 0 for that one. Alright, if I plug in 1, alright, so log base 3, log base 3 of 1 plus 1, that gives me 0.63. I'm just going to say 6, so 0.6. If I plug in 2, so I'd have log base 3 of 2 plus 1. That gives me 1. So then I can graph this. So the first point is at 0, 0. The next point is at 1.6. So 1.6, that's almost half. Okay. And then 2, 1. So 2, 1. And so then remember what the shape of your log function looks like. So it has the asymptote through those points, and it's increasing slowly without doubt. And so there will be the graph of that logarithmic function. Not too bad at all. All right, let's do one more. All right, and so let's say I want you to graph this function. So log base 2 of x minus 4 plus 1. Again, the first thing you want to do is determine where the asymptote is. And in this case, the asymptote would be at positive 4, so it's the opposite. So then 1, 2, 3, 4. And then let me draw the asymptote for that. So, and then remember, once you get your asymptote, we're going to do your t-table. So your t-table are numbers that are bigger than 4. So I'll do 5, 6, and 7. And again, you can plug that into the calculator. So it's log base 2 minus 4 plus 1. So log base 2, so log base 2 of x minus 4. So we said 5 was the first number. 5 minus 4. And it's log base 2. That was plus 1. So you should get 1. Let me double check and make sure that was correct. So x minus 4 plus 1. X minus 4 plus 1. X minus 4 plus 1 is log base 2. So yeah, so you get 1 for that one. Put a 1 there. Right, now do the same thing, but do 6 this time. So 6. So log base 2 of 6 minus 4. And outside parentheses plus 1, you should do 2. Alright, so 2. Now 7. So then log base 2 of 7 minus 4 plus 1, and that gives me 2.6, so 2.58. That's the 2.6. And we can just graph those functions, so 5, 6, or those points, so 5, 6, 7. So 1, 2, 3. Right, so 5, 1. 6, 2, and then 7, 2.6. And then connect those with your log shape, and that will be the graph of that log. All right, that's it for today's lesson.